Hi, my name is Rima Tan, and I'm the Director of Training Data for Project M at IPMD. It is a great honor for us to participate and deliver the Phase 2 demo in the 2020-2021 VA AI Tech Sprint under the Mental Cohort subgroups. We would also like to give special thanks to the National Artificial Intelligence Institute for hosting this amazing event. I will be delivering a full demo and presentation of Project M versus Microsoft and then discuss the screening results. But before that, I would like to introduce my colleague who will be delivering a demo and presentation today. Hi, Scott. Can you please introduce yourself?
Hi, my name is Scott Alexander, and I am the PR and Marketing Director for Project M at IPMD Incorporated. I will brief the full development pathways of Project M today and how we are confident that we will complete the first milestones and the final milestones throughout the sprint.
Thank you, Scott. So our Phase 2 demo objectives are: first, we start off with Scott, who will demonstrate Project M development pathways. Then I will present a full demo of Project M versus Microsoft and discuss the screening results. And lastly, I will briefly present the introduction of our final demo. So Scott, would you please start for your briefing?
Thank you, Rima. Our first milestone was to launch Project M via web testing so that everyone can enjoy it. I'm going to go over how the training of our system made this milestone possible. Data is collected from any video source, then labeled and uploaded to Google Drive. The training data is then imported to the custom-built training algorithm using AWS EC2 P3.exe large machine with 4 V100 GPUs. What you see here is an example of a printout from training for the first model. This is another model because to achieve optimal results, multiple models are trained and the best performing models are used to build an ensemble model. Multiple ensemble models will then be created to achieve optimal results in our finished project. The combinations of this ensemble models perform the best when the models range from slightly underfit to slightly overfit, and they come together to enhance each other's results. During the creation of each ensemble model, they will be validated by both validation algorithms and human experts. The models that failed the validation process will be removed, and those that pass are to be kept. The final ensemble models selected will then be converted for TensorFlow session parameters. Human emotions are extremely complicated, so we rely on our in-house human experts to validate the best performing models. This is because we are using 8 emotions as labels, but there are about 400,000 possible combinations of emotions, so many of the 8 basic emotions labels overlap that traditional AI ML validation methods, therefore won't work in this case. For example, assume that a woman saw her boyfriend is dating another woman. Then the interpretation of her emotions could be a combination of anger, sad, disgust, and/or surprise. Depending on her emotional states, her state of emotion may just be one key emotion or a combination of the said emotions. Because of these reasons, the current standard validation methods of AI/ML won't work for Project M, and our in-house human experts validation is much more trustworthy and credible. The serving TensorFlow model is used on an AWS EC2 T3.xlarge machine. This slide shows the loading of the models on the serving EC2 machine where the models are served. This is the serving image process printout that occurs when the machine is running. Accessing of the serving is accomplished with REST calls. This is the process of serving the Django project on AWS EC2 T3.xlarge machine. It is utilizing AWS S3 storage as the user image data storage and will create the Django project for the testing website application. The next process is uploading the Django application on GCP VM with GitHub. The final step is using AWS Elastic Beanstalk and UWSGI to serve the website on a AWS EC2 T3.xlarge machine. This is the end of my session, and I will hand over to Rima for the full Project M demo. Thank you.
Thank you, Scott, for the presentation. Now I will be presenting a full demo of Project M versus Microsoft Azure. These images I'm going to use for this demo are completely new and never been used for training M, which is a fair game for both platforms. Now I will start with our first challenge. Can emotional AI correctly identify fake smiles? So I'll start off with the first image. So this woman in the image is displaying a fake smile because she is in an uncomfortable and awkward situation and feeling embarrassed in public. As you can see, M identifies her primary emotion as disgust at 88% as her primary emotion. And that's because when a person fakes a smile in awkward and uncomfortable situations, they're trying to cover up their true feelings of discomfort by forcing them to smile in public. M also identifies her mood as negative at 98%, which means she feels discomfort, which leads to the negative mood. So why do people laugh in embarrassed and awkward situation? Well, according to the research, it's known as nervous laughter, which is called as incongruous emotion. You experience an emotion when the situation doesn't necessarily call for it. Some research suggests that nervous laughter may be a defense mechanism against negative emotions that may make us feel weak and vulnerable. Laughter has an effect of discharging energy, helping us relax and regulate our emotional state. One of the research found that laughter activates the endorphin system in the brain that help us withstand pain, calm down when we experience pain and discomfort. Now, let's test Microsoft using the same image. As you can see, Microsoft Azure identifies your emotional state as happy at 99% as the primary emotion, which is incorrect because you never feel true happiness in situations like discomfort, awkwardness, and embarrassment. So why does Microsoft fail to identify a fake smile? And the reason is that Microsoft Azure uses computer vision technology that identifies human emotions based on facial muscle movements. And people never reveal their true emotional states through facial muscle movement and often fake them. If there are no facial muscle movement or they are not genuine, then the AI is not able to identify human emotions correctly just based on facial looks and therefore leads to incorrect results. And now let's test our next image. Our next challenge, can emotional AI identify subtle negative emotions? So her name is Pinky and she is reprimanding her servant for his inappropriate behavior in front of her guest. M correctly identifies her emotional state as anger at 60% as the primary emotion and fear at 10% as the secondary emotion, and the negative mood at 98%. So when you reprimand someone for a misbehavior, inappropriate behavior, a person experiences a negative emotion such as anger in this case. For the secondary emotion, fear that M identifies here could be to the fact that this inappropriate behavior shocked her, which can be translated into fear. In fact, anger starts with the amygdala stimulating the hypothalamus, much like in the fear response, and people with damage to this area often have trouble controlling their emotions, especially anger and aggression. Now let's test Microsoft Azure using the same image. As you can see, Microsoft identifies your primary emotion as neutral at 99%, which means that she is not experiencing any emotions at this moment, and that is not correct as we discussed earlier. It could be due to the fact that her face doesn't exhibit much of facial muscle movement, which is why Microsoft incorrectly identifies neutral as the primary and only emotion. Our next challenge, can emotional AI correctly identify obvious negative emotions with high intensity, such as mad and furious? As you can see in this picture, this man is pretty mad, and what's happening here is that he is reprimanding his subordinate who sabotaged a crucial mission. M correctly identifies his primary emotion anger at 74%, his secondary emotion disgust at 15%, and negative mood at 98%. And this man is also feeling disgusted towards his employee and the failed mission. Now let's test for Microsoft Azure using the same image. As you can see, Microsoft incorrectly reads his primary emotion as happy at 60% and only 35% anger. So the reason is because the technology reads the facial muscle movement around his mouth. It mistakenly thinks that this man is smiling, and he's displaying somewhat similar facial muscle movement when you smile. For the 35% anger that Microsoft Azure identified correctly here is because of the facial expression he's displaying, such as furrowed eyebrows, which can indicate anger. Our next challenge: can emotional AI identify enjoyment from facial looks? This is Rose, a professor who has lots of troubles in her life, but despite all her troubles, right at this moment, she is eating the food that she loves, that makes her forget about the problems and constant worries about her future. As you can see, M identifies your emotional state as happy at 82% as the primary emotion and contempt at 11% as the secondary emotion. M also correctly identifies your positive mood at 97%. So when we enjoy something that we like, as Rose does enjoying her favorite food, endorphins and dopamines are released that makes us feel happy. In fact, those happy hormones can regulate mood, promote positive feelings such as happiness and pleasure, and this is what Rose's emotional state is at this moment. When endorphins are released in the body, they may help reduce stress and anxiety. For the secondary emotion contempt that Emma identifies here is that despite all the trouble, she feels confident that she will be all right. In fact, positive feelings make you feel confident and optimistic, thus giving your self esteem a boost. And this is exactly what M identifies here. Let's test Microsoft Azure using the same image. So Microsoft Azure identifies your primary emotion as happy, but only at 57%, and neutral at 40%, which means that she is not experiencing any emotions at this moment. And this is not correct, as we discussed earlier. It could be due to the fact that her upper part of the face doesn't exhibit much of facial muscle movement, which is why Microsoft Azure incorrectly identifies neutral as the secondary emotion.
Thanks, Rima, for the wonderful demonstration. This is the end of our first milestone, Phase 2. Now I would like to introduce the plan for our final demonstration that will be held in early April. For the final demonstration, we will achieve the proof of concept development of Project M-based mental telehealth platform. In order for us to achieve this goal, the first step is to accomplish real-time detections of human emotions from a continuous video feed. I will now show our project demo done by Daniel Vu, who is our Director of Full Stack Development and Engineering. Here Daniel goes over the configuration of the local environment. These are the models that we are using for Project M. Some rely on Keras using TensorFlow. We are using OpenCV and EmuTools to start recording on cameras and reading the image data. We are using NumPy for pre-processing data before sending it to model for evaluation. For the purpose of this demo, the model is being loaded directly from local machines. But for Project M website, we use TensorFlow serving. Now on with the demo. The green square is being used to capture Daniel's face. On the top left of the square is the model's prediction of the emotion on Daniel's face. Notice, as he keeps his face still, the emotion detected is neutral. When Daniel smiles, the model detects happy. But because he is not genuinely happy the whole time, the model also at times detects contempt. This is the conceptual web design of our mental telehealth platform that will be supported by Project M. This is our development goal for after the final demo. This is the end of our Phase 2 demo for the VA AI Tech Sprint. We'd like to thank Dr. Fricks for guiding us throughout this amazing sprint. We are very confident that Project M can make a difference in veterans' lives and medical staff as well. Thank you.